Next big section is transformation of graphs. Before we can start transforming and moving and shifting and stretching and shrinking and doing stuff to functions, we need to go through and talk about the basic functions. You should be able to recognize what a basic function looks like. So the first section here is recognizing basic functions. If you see a function of the form y equals mx plus b, you should know that that's a line. If you see a function y equals a number, you should know that it's a line, and in particular it's a horizontal line. Yes? Yes. Okay, we've talked about those two in the last few sections. That should be nothing new. Something I want you to think about, though, what is the domain of a linear function? All real numbers. For this one, what is the range? All real numbers. And for this one, what is the range? Whatever that y number is, right? So we're going to call it the number b. Yes? All right. The identity function, it is a linear function. It's y equals x. Something to notice, some special points on y equals x. 0, 0, 1, 1, and -1, -1. Those are the three values I would go no on the identity function. Again, if we want to talk about the domain and the range, both of them are all real numbers. Agreed? Okay, next one. The quadratic function, y equals x squared. That's your parent graph, y equals x squared. Points on that graph. You have 0, 0, 1, 1, and -1, 1. So I usually go after those 3 points. What is the domain of a quadratic function? What x values? All real numbers. But on this parent function, what's the range? Where does it start on the x or on the y-axis? Starts at 0 and then goes up to infinity. I'm going to pause and we're going to stand up and do some arm motions. Cubic. Y equals x cubed. Some points that you need to know on that parent function. 0, 0, 1, 1, -1, -1. Okay, who else had those 3 points? The identity function, right? But does the identity function look like the cubic function? No. The identity function, your arms should be straight because it's a line. Y equals x. But the cubic function, y equals x cubed, is going to be bent. Your arms are going to be curved. Your right arm should be going up. Your left arm should be going down. You agree? Yes. Okay, domain and range of the cubic. What are they? All reals. Square root. It's one arm. Square root function. Y equals square root of x. Points on the square root of x include 0, 0, 1, 1, and 4, 2. Those are the 3 I remember. You're going to need these points because when we start moving stuff, if you've put those 3 points on, you can move it better. Okay, domain and range of the square root. So the domain starts at 0 and goes up to infinity. What am I talking about when I'm saying that? These x values have points. When I'm doing the range, what is the range? So when I look at my y values, these y values have points associated with them, yes? So my range is 0 to infinity. Let's go do one more, and then we're going to pause and do hand motions again. Y equals the cubed root of x. Points on that. I have 0, 0, 1, 1, and negative 1, negative 1. Oh man, those are the 3 points on the identity and on the x cubed.
There's 3 above the square sign?
Yes. It's y equals the cubed root of x. That 3 is the index. Okay, so these are the 3 points again. Domain and range. All reals, both of them. We get to dance. Y equals the absolute value of x. 0, 0, 1, 1, negative 1, 1. And it's a V. It's a V. Those are your points that you need to know. Okay, domain and range. Domain is all reals. Is the range all reals? No. Where does it start? 0. So the range is 0 to infinity. It kind of looks like, when you're doing it with your arms, it looks like y equals x squared. But y equal absolute value of x, your arms better be straight. It's a V. Okay, the reciprocal function. Y equals 1 over x. I just remember it that it has 1, 1, and negative 1, negative 1. And it's in the first and third quadrants. It goes like this with your hands. All right? Whereas the reciprocal squared function, y equals 1 over x squared, it has 1, 1, and negative 1, 1. But it's the band conductor. It's in the first and second quadrants. 1 over x is in 1 and 3. 1 over x squared is in 1 and 2. See the difference? Yep. To there. Okay, let's go talk about domain and range on the reciprocal function. What do you notice about the x-axis? Do you ever touch it? No. What do you notice about the y-axis? Do you ever touch it? No, those are called asymptotes, and we're going to get there later on. But those are values that are never crossed. So for the domain, you can do all of these x values, but you can't do 0. And then you can do all of these x values. So how do we say that? To 0. Yep, we're going to go up to 0, but it's a parenthesis because you don't include it. Union. Start again at 0, but don't include it, and go up to infinity. And for the range, same thing, you agree? Because when you're coming in on the range, all these y values are good, but you can't do 0, and then you pick back up for all of those values. Okay, for the reciprocal squared function, domain and range. Coming in, I can pick all these x values. Can I pick 0? No, but I can pick anything to the right of 0. So again, that x equals 0 is called a vertical asymptote. We'll talk about that in another chapter. Our domain is negative infinity to 0, and then 0 to infinity. Okay, what about our range on this one? Can I pick any of these y values? No. I can start picking anything bigger than 0. So how do I say that? Parentheses 0 to infinity.